I hope everyone is fine and doing well. We are just waiting for the students to enter into the class. At present, we have 26 students. Last time we have done the derivation. So if you have any questions or queries about the derivation, you can ask me. And I hope there were few steps in the derivation which I told you to solve yourself. So I hope you guys have solved it. If you have not solved it, then what I can share later on the derivation file. By the way, I have opened that file so I can discuss with you if you need any help. And, meanwhile, while the students are coming, we can. There were few steps in the derivation. First, you have calculated the what you say the change in the length along the x-dash direction, and then this was the formula to calculate the transform strain about the x-dash direction. So strain is equal to change in length over the original length, and from our earlier equations we have derived this that dx dash has two components, one along the x-axis, one along the y-axis. So that we have said as dx is equal to dx dash cos theta and dy is equal to dx dash sine theta. So in that equation, basically we have to eliminate this dx dash. Okay, so in that what we did, our change in length was delta x dash, that is epsilon x dx cos theta. So dx we have replaced with dx dash cos theta because in the denominator we have dx dash, so we want to eliminate this factor. Similarly, epsilon y dy sine theta, so dy is dx dash sine theta into sine theta plus gamma xy dy cos theta. So again, we are basically introducing in this equation dx dash so that it cancels out with dx dash in the denominator, and then this is the simplification going on. So epsilon x dash is equal to epsilon x dx dash cos theta into cos theta, so it becomes cos square theta, then epsilon y dx dash sine square theta over dx dash plus gamma xy dx dash sine theta cos theta. So dx dash will cancel out in all the cases, and your final equation you will get this one, epsilon x cos square theta plus epsilon y sine square theta plus gamma xy sine theta cos theta, and then you will put the identities in this equation. Cos square theta is 1 plus cos 2 theta over 2, and sine square theta is 1 minus cos 2 theta over 2. And then we know that 2 sine theta cos theta is sine 2 theta. So because over here you have just sine theta cos theta, so it will become sine 2 theta over 2. So in that case, what you say, epsilon x dash, further simplified epsilon x, you will open up these brackets and you will get epsilon x over 2 plus epsilon x cos 2 theta over 2 plus epsilon y over 2 minus epsilon y over 2 cos 2 theta plus gamma xy sine 2 theta over 2, and after cumulating you will separate out the theta and non-theta values. So this will become epsilon x over 2 plus epsilon y over 2. So this is epsilon x plus epsilon y over 2 plus epsilon x over 2 cos 2 theta minus epsilon y over 2 cos 2 theta. Okay, so this will become epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sine 2 theta. Okay, is this fine? These were the steps which were not given in the book as well. Similarly, in case of tau x dash y dash, when you calculated the alpha, that was delta y dash, the deformations along the y dash axis, you got this epsilon x dx sine theta plus this was the deformation due to epsilon y, this was the deformation due to the shear strain gamma xy. So you have equated delta y dash in this equation, and then again you have dx dash in the denominator. So you will put dx, dy and dy in terms of dx dash so that you can eliminate this dx dash from the equation. And once you will simplify alpha, so minus epsilon x dx dash cos theta sin theta dx dash plus epsilon y dx dash sin theta cos theta over dx dash minus gamma x y dx dash sin theta into sin theta over dx dash. So when you will cancel out dx dash, you will get this minus epsilon x cos theta sin theta plus epsilon y cos theta sin theta minus gamma xy sin square theta. In this case, you have not put the identities in this equation. The reason is that your gamma x dash y dash is basically change in the angle, which was alpha minus beta. Okay. So similarly, you have calculated the beta. Beta was like the same theta plus 90. So wherever you have theta, you will replace theta with theta plus 90, theta plus 90, theta plus 90. And once you have what you say this beta value, you have simplified this, and then alpha minus beta. Okay. So this is your further what you have to simplify. ठीक है कि इसमें ये है कि when you will do it, that first open up this brackets. ठीक है, solve these two brackets and then open up these smaller brackets. There are 31 students. I think we should start with our today's lecture. So last time we have derived these equations. Epsilon x dash is equal to epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sin 2 theta. And your shear strain equation is gamma x dash y dash over 2 is equal to minus epsilon x minus epsilon y over 2 sin 2 theta plus gamma xy over 2 cos 2 theta. These two equations are exactly similar to your stress transformation equations. Only difference over here is uh, sigma x corresponds to epsilon x, sigma y will correspond to epsilon y. The difference is here that the shear stress tau xy will correspond to gamma xy over 2. Tau xy will correspond to gamma xy over 2. So in your shear stress equations, stress transformation equations, you had tau xy here. And in strain transformation equations, tau xy will correspond to gamma xy over 2. So last time we have done this this normal and shear strain transformation equations. Now today we will start with our principal strain equations. So principal strains. Just before we start principal strain, if you recall in case of the principal stress derivation, okay, what you have done that you have differentiated equation of the sigma x dash transformed normal stress, okay, with respect to theta, and then you equated that equation equal to 0, and after simplification you got this tan 2 theta p is equal to 2 times tau xy over sigma x minus sigma y. One thing to be noted here, sigma x corresponds here to epsilon x. So sigma x will only produce epsilon x because Poisson's effect is taken as 0, and sigma y will produce strain epsilon y, and the shear stress tau xy will produce shear strain gamma xy. As I have said earlier, that the shear stress tau xy will produce the shear strain gamma xy over 2. In your stress transformation equation, over here it was in the numerator, it was 2 times tau xy. So that's why you are having gamma xy over 2 into 2. So you will get gamma xy. If you need to derive this equation, what will you do? आप क्या करेंगे? You will differentiate this equation, epsilon x dash equation, ठीक है जी, with respect to theta, and then you will equate it equal to 0. So the derivation, so the method to get the equation for the principal strains and for the principal planes for the strain state, ठीक है, plane state of strain, in that you will differentiate this equation, ठीक है जी, epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sin 2 theta equation with respect to theta, and then you will equate it equal to 0, and you will get the orientation, ठीक है जी, which will be your orientation of the principal planes. So that equation is gamma xy over epsilon x minus epsilon y. Then to calculate the principal strains, the equation is exactly similar to the equation for the computation of the principal stresses. Only difference is that sigma x is replaced with epsilon x, sigma y is replaced with epsilon y, and tau xy is replaced with gamma xy over 2. Gamma xy over 2. So let's start with the principal strains first. Like stress, an element can be oriented at a point so that element's deformation is caused only by normal strains with no shear strain. As we have said earlier, that over the principal planes there will only be normal stresses, there will be no shear stresses. So it means uh, normal stresses will produce normal strains. Shear stress, as there is no shear stress, so consequently there is no shear strain over the principal planes. ठीक है जी? So when this occurs, the normal strains are referred to as the principal strains. And if the material is isotropic, isotropic means that the material has same property in different directions. So if the material is isotropic, the axis along which these strains occur will coincide with the axis that defines the planes of principal stresses. Because our material is isotropic, so you can say the principal planes that you will get by using a plane state of strain, and principal axis that you will get by using what you say plane state of stress, they will be same. So the formula which you have derived earlier in case of the stress transformation and this formula, they both will give us the same value of the theta p1 and theta p2. So now next thing is the computation of the principal strains. There are two ways to calculate the principal strains. One is that you get the value of theta p1 and theta p2 from equation 10.8. You can put these values of theta p1 and theta p2 one by one in this equation 10.5. So the normal strain that you will get from this equation, those strains will correspond to your principal strains, because theta p1 and theta p2 are your orientation of the principal planes. Other way around is to get the direct what you say direct formula to calculate the principal strains, that is epsilon 1 epsilon 2 is equal to epsilon x plus epsilon y over 2 plus minus under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. So it's this equation is exactly same as for the calculation of the principal stresses, as for the calculation of the principal stresses, and the derivation of this equation involves that if you recall the figure which we have drawn, the triangles and We said that 10 is positive in the first and third quadrant. ठीक है जी? And then we also calculated the resultant. So basically your principal strain is average strain plus minus the resultant. Principal strain आपका क्या है? Principal strain is average strain plus minus resultant. ठीक है जी? So epsilon 1 is the maximum value of the normal strain, or you can say the major principal strain. So that will be average strain plus the resultant. Epsilon 2, that will be average strain minus the resultant. ठीक है जी? Epsilon 2 will always be smaller than epsilon 1. If you have any question about this, you can ask me now. So equations 9.4 and 9.5 and the correspondence between stress and the strain mentioned above, the direction of the x dash axis and the two values of the plane strains, principal strains epsilon 1 and epsilon 2 are determined from. So it's the same what we are saying, that first you can take the derivative of equation. There's epsilon, sorry. So you can take the derivative of this equation epsilon x dash, ठीक है जी, with respect to theta, and then you equate it equal to 0. You will get the expression for the computation of orientation of the principal planes. And because our material is isotropic, so the orientation of the principal planes in case of plane stress and in case of plane strain, it will be same. It will be same. For the calculation of the principal strains, you have one formula, and the other way around is you just put the value of theta p1 and theta p2 in epsilon x dash equation. Next is your maximum in plane shear strain. Maximum in plane shear strain. So the calculation of the maximum in plane shear strain is similar to the maximum in plane shear stress. So if you recall, in maximum in plane shear stress case, we differentiated the equation with respect for the tau x dash y dash with respect to theta, and then we equated that equation equal to 0. We differentiated the equation, ठीक है जी, with respect to theta, and then we equated that equal to 0. ठीक है जी, and the expression that we finally got, that was tan to theta s is equal to minus times epsilon x minus epsilon y over gamma xy. Epsilon x minus epsilon y over gamma x y. ठीक है जी? Difference is normal stress corresponds to normal strain. Epsilon x normal stress, the sigma y corresponds to normal strain epsilon y, and the shear stress over earlier it was 2 times tau xy. So 2 tau xy will correspond to shear strain gamma xy. Then similar to the maximum in plane shear stress equation, that is similar to this, we have the maximum in plane shear strain equation, and you can see this, this is gamma by 2, ठीक है जी, gamma by 2, and that is equal to under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square, ठीक है जी, and this is basically equal to the resultant. So if you recall, and we can also see this in case of our Mohawk circle, that the maximum in plane shear strain will be equal to radius, ठीक है जी. Principal stresses and principal strains are basically average, in this case average strain plus minus resultant, this is just equal to the resultant, ठीक है जी. So maximum in plane shear strain is equal to the resultant. So gamma maximum in plane over 2 will be equal to under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square, and your average strain formula is the same. average strain is epsilon x plus epsilon y over 2. ठीक है जी, average strain. And if you recall, we have said that over the principal planes we will only have normal strain. We will not have the shear strain. And similarly, we have said that over the shear planes, we will have maximum in-plane shear stress, earlier we have said, and the average normal stress. So over here, in case of the plane state of the strain, over this shear strain axis, we will have what you say maximum in-plane shear strain and the associated average normal strain. ठीक है जी? So associated average normal strain. So there are a few important points which needs to be kept in mind. First one, in case of the plane strain analysis may be used with the plane of the stresses to analyze the data from the strain gauges. Remember though, there will be a normal strain that is perpendicular to the strain gauges due to the Poisson's effect. Now, let me explain this. We have said earlier that the strain gauge will only measure the strain in the direction in which it is attached. So it means that your strain gauge will only measure the normal strain. Strain gauges will not give you the shear strain or lateral strain values. If you want to compute lateral strain or shear strain, then you have to use the relationships. So those relationships we will derive later on in this week, where we will develop the relationship between the stress and the strain using material property relationship, using modulus of elasticity and Poisson's ratio. At present, for the plane state of the strain, we have said that the Poisson's effect is 0. For the plane state of the strain, we have said that Poisson's ratio is 0. Otherwise you will not have the plane state of strain. So when the state of the strain is represented by the principal strains, no shear strain will act on the element. Over the principal planes, we know that there will be only shear stresses and correspondingly there will be only, over the principal planes there will only be normal stresses. So correspondingly there will only be normal strains. So because there is no shear stress, so correspondingly there will be no shear strain over the principal planes. The state of the strain at a point can also be represented in terms of the maximum in-plane shear strain. In that case, an average normal strain will also act on the element. So over the shear planes, you will have the maximum in-plane shear strain and the average associated normal strain. Then we have said the element representing the maximum in-plane shear strain and its associated average normal strains is 45 degrees from the orientation of an element representing the principal strain. So if you recall, we have said that 2 theta P1 and 2 theta P2, they will be 180 degrees apart. Similarly, 2 theta S1 and 2 theta S2, they will be 180 degrees apart. So 2 theta P1 and 2 theta S1 will be 90 degrees apart. However, your theta P1 and theta S1 will be 45 degrees apart. So this we can further prove with the help of the numericals that we are going to do now. So please take out your registers and pencils so that we can start the numerical. If you guys are ready, then let's start with the numerical. So a differential element, a differential element is given of material at a point is subjected to a state of plane strain. Epsilon x is 500 microstrains, epsilon y is minus 300 microstrains. Shear strain gamma xy is 200 microstrains. Here epsilon x is positive 500 microstrains, epsilon y is minus 300 microstrains. Gamma xy shear strain is positive 200. So now this means that your normal strain epsilon x, it is resulting in the elongation of the element. Your normal strain epsilon y is resulting in the shortening or contraction of the element. Your shear strain is positive, which means that your element, its angle AOB is less than 90 degrees. So if you focus on this figure, you will see that this solid shape is your actual element. Dimension in the x direction is dx, dimension in the y was dy. And after the application of the stresses, this is the deformed shape of the element. This is the deformed shape of the element. So along the x-axis, you can see that there is elongation in the length. Now strain is epsilon x and the change in length over original length. So original length is dx, so change in length is epsilon x strain times the original length. So the change in length is epsilon x dx. Then along dy, you can see that there is shortening of the length. Epsilon y dy is the change in the length along the y-axis, and this is the shortening. And then the shear strain, you can see this actual element. In the actual element, this angle is 90 degrees. In the actual element, this angle is 90 degrees. So this angle AOB in the deformed shape has reduced. So it means your shear strain is positive, which tends to distort the element as shown in the figure. You are required to determine the equivalent strains acting on an element of the material oriented at the point clockwise 30 degrees from the original position. Clockwise 30 degrees from the original position. So guys, you need to calculate the transformed, what you say, normal strains epsilon x dash and epsilon y dash and gamma x dash y dash. Okay, जी? And epsilon x is 500 microstrains, epsilon y is minus 300 microstrains, and your gamma xy, the shear strain, is 200 microstrains. Theta is clockwise 30, clockwise is negative, so theta is minus 30 degrees. Ji, please calculate epsilon x dash. What's the value of epsilon x dash? 2, 1, can you repeat? And it is microstrains because epsilon x dash is equal to epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sine 2 theta. ठीक है जी, so your shear strain value is your shear strain value, your normal strain value is 213. I think so. If you want to have what you say answer to one decimal place in case of the strains, that is sufficient. And if you don't want to have any decimal place, that is still sufficient because the answer is in microstrains. This actually represents 0.0 decimal, then 000, then 2134. So you can see the value is already very small. So we can have the value, what you say, just rounded value rather than having a value in decimal figures. So normal strain epsilon x dash is 213 microstrains. Can you please calculate epsilon y dash now? वो shear strain है. I am asking epsilon. I am asking you epsilon y dash first. Microstrains. ठीक है जी. So what you should do when you calculate epsilon x dash, that should be epsilon x dash should be equal to epsilon x plus epsilon y over 2. ठीक है जी. Found the value of this part plus epsilon x minus epsilon y over 2 cos 2 theta. Find the value of this part plus gamma xy over 2 sin 2 theta. Find the value of this part. ठीक है जी. And then when you calculate epsilon y dash, only your signs are negative. So for this part, epsilon x plus epsilon y over 2, I have value as 100 microstrains. Epsilon x minus epsilon y over 2 cos 2 theta value, I have 200 microstrains. And this gamma x y over 2 sine 2 theta is minus 86.6 microstrains. So when you will calculate epsilon y dash, you just have to put negative signs, and then it's relatively easier to calculate it. So if you have calculated epsilon x dash and epsilon y dash, then please calculate gamma x dash y dash over 2 shear strain value. जी shear strain value please. बाकी जो लोग हैं, आर दे प्रेजेंट आपकी क्लास?
Yes sir, we are present.
You guys do not participate, ठीक है ना? We do not want sleeping students in the class. I'm very much clear that I have already decided that I will deduct the marks of whole of your class in your class participation, and you will see this in your result. Because this section B is they do not participate. They are just sitting idle, doing nothing. Just 1 or 2 students if they feel. What sort of the CR you are, Uzair? what sort of shear you are? You do not participate any type in the class. क्या मसला है आप लोगों का? मैं जब आपको कह रहा हूँ कि मुझे आंसर्स बताएं तो आप लोग बैठे हुए हैं मुंह उठा के। बताएं shear स्ट्रेन की वैल्यू। कोई पार्टिसिपेट करें, कोई आंसर्स कैलकुलेट करें। व्हाट यू गाइस आर डूइंग?
Sir, 792.82 multiplied to the power -6.
I have just a few moments ago I have told then when you are reporting the value of the strain, it's not advisable to report the values in decimal places because it's already very small value. It is better to report in rounded figures 793 microstrain. So this is basically 0.000793 actual strain. ठीक है जी, 0.000793, so already very small value. If you are done with this, this is the figure which they are drawing, showing this is your x-axis and this is your transformed x-axis, which is at an angle theta, 30 degrees clockwise, that is theta minus 30. ठीक है जी, now recalculate the normal strain and shear strain values. Recalculate the values of epsilon x dash, epsilon y dash and gamma x dash y dash for theta 60 degrees. So if your element is oriented at an angle theta 60 degrees counterclockwise, which means theta is positive. So with theta 60 degrees positive, please recalculate epsilon x dash, epsilon y dash and gamma x dash y dash. Please calculate and let me know the answer when you are ready.
Sir, epsilon x dash is minus 13.4 micro.
Epsilon y dash, epsilon y dash. Why? Okay. Microstrains. If you will report the value, rounded value, that's also fine with me. There is no problem. जी
Sir, minus 79.3 10 to the power -6.
always report the strains in terms of micro strains, 10 raised to minus 6. So shear strain is 793 micro strains. Now, the point which I want to explain to you, this black dotted line is your regular or your actual x and y axis. ठीक है जी, ये जो this black dotted lines, these are your actual x and y axis. Fine. Then in the first case, you had theta minus 30 degrees. So theta minus 30 degrees means that all your x dash axis is oriented at an angle theta 30 degrees clockwise, theta minus 30. So all your angles will be oriented at theta minus 30. So this is your x dash axis, this is y dash, x dash, y dash axis. Normal strain about the x dash axis, that is epsilon x dash, you guys have reported as 213 microstrains, and normal strain about y dash axis epsilon y dash, you guys have reported minus 13.4 microstrains. Epsilon y dash is reported as minus 13.4 microstrains. ठीक है जी. Now in the second case, I asked you that your element is oriented at an angle theta 60 degrees counterclockwise. Theta 60 degrees counterclockwise. So now in that case, you can see with respect to x-axis, your element is oriented at an angle theta positive. So this is your x double dash axis. Then your y dash axis is also oriented at positive 60 degrees. So this is your y double dash axis. Then this is your x double dash axis. This is your y double dash axis. Now, in this case, you have calculated epsilon x double dash basically as minus 13.4 and epsilon y dash as 213.4. Now, if you see this along x dash and y double dash, epsilon x dash 213, epsilon y double dash 230. So basically, over the plane, ठीक है जी, your strain is 213 microstrains. So over the plane, your strain is 213 microstrains. ठीक है जी, and over this plane, your strain is minus 13.4 microstrains. The point to be noted here that the strain, the strain over the plane will remain same whether you designate it as x dash axis or y dash axis, but the strain over the plane remains the same. Is this point clear?
Yes, sir.
Earlier I have told you that over the plane, your stress will remain the same, whether it's the x-axis or y-axis. So correspondingly here, your strain will remain the same, whether over the plane, whether it is x or y-axis. Let's start the next example, that is 10.2. 10.2. Guys, this is the final state of the element which we have to present. ठीक है जी? You can see this over here. They are just showing, you have to show epsilon x dash and epsilon y dash. ठीक है जी? They are already showing you this epsilon y dash dy dash negative and epsilon x dash dx dash positive. Shear strain is also positive, gamma x dash y dash over 2, gamma x dash y dash over 2. Chilling. Next question. Next question is, example is 10.2, and question is, a differential element of material at a point is subjected to a state of plane strain defined by epsilon x, that is minus 350 microstrains. Epsilon y is 200 microstrains. Gamma xy is 80 microstrains. ठीक है जी? So which tends to distort the element as shown in the figure. So this is your element. ठीक है जी? Actual element. After the application of the stresses, this dotted shape is the distorted shape of the element. So along the dx, there is a reduction in the length. You can see epsilon x dx is compressive. So it means your strain epsilon x is compressive. It resulted in the reduction in the length. Then along the dy, you have increase in the length, which means that this strain has resulted in the elongation of the element. Then your shear strain, this angle has reduced from 90 degrees. So gamma xy by 2, gamma xy by 2. So it is positive. So we are required to determine the principal strains and the associated orientation of the element. So to calculate the associated orientation of the element, you have the formula for this, because we are basically asked to calculate the orientation of the principal plane. So orientation of the principal plane will be equal to tan 2 theta p is equal to gamma xy over epsilon x minus epsilon y. So please calculate this.
So minus 8.275 degree 2 theta p.
Yeah, you are basically calculating 2 theta p. You have to calculate आपने 2 theta p you have calculated. एक आपका आ रहा है minus 8.28 and other one is other one is 171.72.
Yes, sir.
Yes, sir.
171.7.
So please calculate theta p1 and theta p2. ये जो आपने अभी वैल्यू बताई है 4.138, इट डज नॉट मेक मच सेंस. इसको राउंड अप कर दें टू 1 डेसिमल प्लेस. थीटा 1 डेसिमल प्लेस सफिशिएंट है. आगे बताएं. सेकंड वैल्यू
85.9.
okay guys, one thing you have to do, that the difference between these two angles must be exactly 90 degrees. ठीक है? Otherwise you will get the rounding error, and when you will use these theta values to calculate the shear strain, you will not get zero value for the shear strain. You will get some value. So that value is basically because of the rounding errors. ठीक है? So you have to ensure that theta p1 and theta p2, those values are up to 1 decimal place, and the difference between the two values theta p1 and theta p2 is exactly 90 degrees. Okay.
Yes, sir.
Okay, sir.
So once you have theta p value, in the book as well, they are not keeping it exactly 90. So that should not be the way. They should have kept these values Like this should be minus 4.1 and this is 85.9, then the difference will be exactly 90 degrees. ठीक है जी? So next thing is we need to calculate the principal strains. One way is you can calculate the principal strains directly using this equation. Other way around is you have the values of theta p. You put the value of theta p in equation 10(8) and you calculate the principal strains. So I would suggest you guys to put the value of theta p first minus 4.1 and then 85.9. ठीक है जी, in this equation and calculate the transformed normal strain. But because you are putting the or principal plane orientation, you will get the strains as principal strains. So first please put the value theta minus 4.1. 4 ना कीजिएगा, 4.1 degrees and let me know the answer. So this minus 353. So this is your negative value. So it means your theta 85.9 will be your theta p1 and this will be your theta p2 because theta p1 must give us epsilon 1 and theta p2 must give us epsilon 2. ठीक है जी? अब आप theta 85.9 degrees put करें and let me know the answer. आपका आंसर आना चाहिए 202.8 माइक्रोस्ट्रेन्स और 203 माइक्रोस्ट्रेन्स.
So 2.03 10 is power minus 4 or 202.9
उज़ैर एक सेकंड, मैंने आपको ना कुछ moments ago I told you to report the strain in terms of 10 raised to minus 6 and not in terms of 10 raised to minus 4. ठीक है? Report the strains in terms of 10 raised to minus 6. जी बोले.
So 203 10 is power minus.
So theta p1 will be 85.9 and theta p2 will be minus 4.1 and epsilon 1 will be 203 microstrains, epsilon 2 will be minus 353 microstrains. If you have calculated the exact values are 20 epsilon 1 as 202.8 microstrains and epsilon 2 is minus 352.8 microstrains. Next question, please. Guys, you have to show this answers on the element as well. You can see this, they are showing it. Minus 4.14 and 85.9. Okay, so over this, you are having principal strain epsilon 1 and over it you have the principal strain epsilon 2. You can see this, they are showing the positive strain over this y dash axis, which is basically your theta p1 and this is your epsilon 1, and over this x dash axis, which is minus 4.1 degrees, which is negative, and you can see the strain is also negative. So you have to draw this figure as well. Okay? So this is basically we have to present our results in the form of the figure as well. Now next question. Similar data is given. Again, a differential element of a material at a point is subjected to a state of plane strain, which is defined by epsilon x minus 350 microstrains, epsilon y is 200 microstrains, and gamma xy is 80 microstrains. So again, epsilon x is minus, so it means there is a reduction in the length along the x-axis, and along the y-axis you have increase in the length as your strain epsilon y is 200 microstrains, and your shear strain is positive as your angle AOB is reducing. In this case, we are being asked to calculate the maximum in plane shear strain. ठीक है जी, we are asked to calculate the maximum in plane shear strain at the point and the associated orientation of the element. Associated orientation of the element. So guys, first of all, we have to calculate the orientation of the shear plane. So tan 2 theta s is equal to minus times epsilon x minus epsilon y over gamma xy. So we have to calculate the value of 2 theta s. So please calculate 2 theta s.
Sir, 81.7 meters.
And the other one will be 261.7. So theta s values will be 40.9, and basically it should be 130.9. ठीक है जी, 40.9 and 130.9. Now, to calculate the maximum in plane shear strain. So, to calculate the maximum in plane shear strain, you can use the direct equation, epsilon x minus epsilon y over 2 square plus gamma x y over 2 square, or you can, what you say, you can use the strain transformation equation, this one. And in this equation, you can first put the value of theta as 40.9, and second, you can put the value of theta as 130.9. So whichever will give you the positive in plane shear strain, that will be your theta S1, and the other value will be your theta S2. So first you can try with, let's say, 40.9 degrees, and let me know the value of the shear strain. Your positive value आई है, that is with theta 40.9. ठीक है, so it means over theta S1 is 40.9 degrees and theta S2 is 130.9 degrees. ठीक है जी. Next thing is we have to calculate the associated average normal strain, epsilon x plus epsilon y over 2. We have to calculate the associated average normal strain. So please calculate it.
-7.
Minus 75 microstrands minus 350
Yes.
plus 200 divided by 2 minus 150 microstrands divided by 2 minus 75 microstrands, and it is negative, so which means it will tend to contract, cause the element to contract. Guys, we will have a short break, and after the break, we will start with Mohawk Circle for the plane strain case. We will start the Mohawk Circle for the plane strain case. Okay? So we will have a break. So we will restart the class at 2:25.
Okay, sir. Yes, sir.
Okay, ji, Bismillah Rahman Rahim. Let's restart our lecture. Uh, Now we are going to do Mohawk Circle. Mohawk Circle for the plane strain. Let me start the recording. Okay, ji, Bismillah Rahman Rahim. Let's start with a new topic, that is Mohawk Circle for plane strain. Since since the equations of the plane strain transformation are mathematically similar to the equations of the plane stress transformation, we have already derived the equations for the plane strain transformation, epsilon x dash, epsilon y dash, and gamma x dash y dash over 2. And we have seen that the plane strain equations are very much similar to the plane stress equations. ठीक है जी? So we can also solve these problems involving the transformation of the strain using Mohawk circle. Mohawk circle, as we have studied earlier, is a graphical solution. ठीक है जी? And it allows us to basically visualize how the normal and the shear strains will vary as the plane over which they act is oriented. So as we will vary the theta, a set of normal and the shear strain will change, or you can say they will vary with the value theta. Like the case for the stress, the parameter theta in equation 10.5 and 10.6 can be eliminated and the result is rewritten. So the derivation is very much similar. Let me show you first. 10, 5 and 10, 6. So these are the equations. So this is the equation for the transformed normal strain. This is the equation for the transformed shear strain. So in these two equations, what you have to do, you have to gather the coefficients without theta. Okay, you have to gather the coefficients without theta on the left hand side. So this will become epsilon x dash. This factor will go on the left hand side, minus epsilon x plus epsilon y over 2. That is equal to epsilon x minus epsilon y over 2 cos 2 theta plus gamma xy over 2 sin 2 theta. And gamma x dash y dash over 2 is equal to minus epsilon x minus epsilon y over 2 sin 2 theta plus gamma xy over 2 cos 2 theta. ठीक है जी. So you have to change the equation, that rewrite the equation in such a way that coefficients with theta will be on the left hand side, without theta will be on the left hand side, and coefficients with theta will be on the right hand side. Then you can eliminate the parameter theta by taking the square of each equation. ठीक है जी, square of each equation, and then you will add the two equations together. ठीक है, you will add the two equations together, and after simplification you will get this expression. So like the case for the stress, the parameter theta in equation 10, 5 and 10, 6 can be eliminated, and the result is rewritten in the form this one. ठीक है जी. So epsilon x dash minus epsilon average square plus gamma x dash y dash over 2 square is equal to r square. Guys, you need to do the derivations. ठीक है जी, I am explaining to you, but you have to do the derivations. These derivations are part of your syllabus. So epsilon average is epsilon x plus epsilon y over 2, and r is basically epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. ठीक है जी. So equation 10, 13, if you recall, in case of the stress plane stress case, you have this as sigma x dash minus sigma average square plus tau x dash y dash square is equal to r square. ठीक है जी. So now in case of the plane strain, this equation is epsilon x dash minus epsilon average square plus gamma x dash y dash over 2 square, which is equal to r square. R is your resultant, and resultant, or you can say the radius, and that is equal to under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. ठीक है जी. Equation 10, 13, this one. Equation 10, 13 represents the equation of Mohawk circle for the strain. ठीक है जी. And this equation basically has a center on the normal strain axis. If you recall, in the case of the plane stress, your center point lies on the normal stress axis. So in this case, your center point will lie on the normal strain axis, and the coordinates of the point C, they are average strain and zero shear strain. So coordinates of the point C will be average strain and zero shear strain, and the radius is r. R is equal to under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. ठीक है जी. Now procedure for the analysis, or you can say steps for the construction of the Mohr circle. ठीक है जी? So construction of the Mohr circle will be very much similar to the construction of the Mohr circle for the plane stress. So plane strain and plane stress, Mohr circles will be very much similar. And the sign convention and the designations like A, B, C, D, E, F, G, they will be the same as they were in the case of the plane stress. So let's start construction of the Mohr circle. So we have to establish a coordinate system such that your x-axis represents the normal strain. So again, normal strains are on the x-axis, just like you have in case of the plane stress. Normal stresses were on the x-axis. So normal strains are on the x-axis. ठीक है जी? With positive to the right. So the normal strains on the positive side will be on the positive x-axis will be positive, and the normal strains on the negative axis will be negative. And the vertical axis, this vertical axis or the ordinate, this vertical axis represent the half the value of the shear strain. So vertical axis represent shear strain gamma by 2. Vertical axis represent the shear strain gamma by 2. ठीक है जी? And downwards is positive, upwards is negative. Why we take downwards positive? So that we have the same orientation as the orientation of the point on the element and the orientation of the point on the Mohr circle. ठीक है जी? Then for the positive sign convention, ठीक है, just like positive sign convention for the plane stress, sigma x, sigma y, and tau xy, we started with positive sign convention for the Mohr circle. So similarly, for this plane strain, we will start with the positive sign convention for epsilon x, epsilon y, and gamma xy. Epsilon x, epsilon y, gamma xy. ठीक है जी? To draw the Mohr circle. So first step is you have to determine the center of the Mohr circle. Guys, again, please remember this. Origin 0, 0 is this one. This is the center of the Mohr circle. So center of the Mohr circle, C, it is which is located on the normal strain axis. ठीक है जी? The center of the Mohr circle C, which is located on the normal strain axis at a distance. The coordinates of the point C are average strain and zero shear strain. ठीक है जी? So determine the center of the circle C, which is located on the normal strain axis at a distance. Distance क्या होगा जी? First you have to calculate the average strain, that is sigma x plus sigma y over 2, and the shear strain is 0. So whatever is the average strain, that will be your coordinate of the point C. So you will first mark the center point of the Mohr circle represented with point C. ठीक है जी? Then next step is you have to plot the reference point A. If you recall, we have said that with the help of the element, we have said that when theta is 0 degrees, means over x dash axis coincides with the x-axis. ठीक है जी? So in that case, over sigma x dash is equal to sigma x, sigma y dash is equal to sigma y, and tau x dash y dash is equal to tau xy. So similarly here, in case of this plane strain, epsilon x dash will be equal to epsilon x, epsilon y dash will be equal to epsilon y, and gamma x dash y dash will be equal to gamma x dash gamma x y. ठीक है जी? So x dash axis coincides with the x axis. ठीक है जी? So theta is 0. So the coordinates of the reference point will be epsilon x and gamma xy over 2. ठीक है जी. Originally, if you recall, in case of the plane stress, your coordinates of the point A were sigma x and tau xy. So over here you will have epsilon x and gamma x by 2. So this is the change, because on the vertical component you have gamma by 2, and this gamma by 2 was derived from the equation where you got sine 2 theta over 2. ठीक है जी. So this 2 came from in the derivation. So your coordinate of the point A will be epsilon x comma gamma xy over 2. So this point will be your reference point A. ठीक है जी. So the reference point A has the coordinates epsilon x and gamma xy over 2. So whatever will be given in the question in the plane strain, that will be your coordinates of the point A. If it is with negative sign, then you have to put the negative sign. So this point represents the case for which x dash axis coincides with the x-axis. ठीक है जी. Theta is 0. ठीक है. Any questions about this third point?
No, sir.
Okay. Then lot, this is done. Then you have to connect the center point of the Mohr circle. You have to connect the center point of the Mohr circle with the reference point A. You have to connect the center point of the Mohr circle with the reference point A, C2A. C2A represents C2A represents the radius of the Mohr circle, or this is also equal to the resultant, which is epsilon x minus epsilon y over 2 square plus gamma xy over 2 square and square root of all of this. ठीक है जी. So that will give you the resultant or the radius of the Mohr circle. So connect the point A with the center C of the Mohr circle, and from the shaded triangle, the radius of the circle R. ठीक है जी. So once you have the radius, you can place your compass at the center point C. ठीक है जी. And plot and open up equal to the radius. ठीक है जी. And then plot this circle. So once R has been determined, sketch the Mohr circle. One more thing which is not written over here, that your scale of the Mohr circle, ठीक है जी, is the scale on the x-axis and the scale on the y-axis. ठीक है जी. It must be same. If you are taking an interval of, let's say, 50 microstrains on x-axis, then the interval of shear strain on the y-axis must also be 50 microstrains. ठीक है जी. So the strains interval on x and y-axis must be same. So any question about this first part?
No, sir.
Okay. Now, next thing is we have to calculate the principal strains. We know that principal strains will occur over the principal planes over which your shear strain values are 0. So we know that over horizontal normal strain axis, shear strain is 0. ठीक है जी. So where your Mohr circle intersects the horizontal axis, ठीक है जी. So these 2 points represents the principal strains. The maximum normal strain will be your what you say major principal strain, and your smaller value of the what you say normal strain will represent the minor principal strains. One more other thing is that you need to determine the orientation of the principal plane. So these are the principal planes. This will be point B. This will be, sorry, this will be B, this will be D. So to calculate the orientation of the principal plane, you will move from the reference line CA in the counterclockwise direction, which is positive because this is we are considering all the parameters as positive in this construction. So moving from the reference line CA, okay, moving from the reference line CA in the counterclockwise direction towards the plane CB. This is basically shown in the figure below. So moving from reference line CA towards CB will give us the orientation of the principal plane. That will be 2 theta P1, and using trigonometry we can calculate 2 theta P1. 2 theta P2, ठीक है, 2 theta P2 will be simply 2 theta P1 plus 180 degrees. So the principal strains epsilon 1 and epsilon 2 are determined from the Mohr circle. ठीक है जी, principal strains epsilon 1 and epsilon 2 are determined from the Mohr circle as the coordinates of points B and points D. ठीक है जी, where the shear strain is 0, where the shear strain is 0. ठीक है जी, the orientation of the plane on which epsilon 1 acts can be determined from the Mohr circle by calculating 2 theta P1 using trigonometry. Here this angle happens to be counterclockwise from the reference from the radial reference line CA, ठीक है जी, towards the line CB. Remember that the orientation of theta P1 must be in this same direction. ठीक है जी, so rotation of the element and rotation on the Mohr circle, they should be same. Rotation means that rotation from x-axis to the x dash axis. So whatever is the direction, if it is counterclockwise theta, then on the Mohr circle that will be counterclockwise to theta. ठीक है जी, so here this angle happens to be counterclockwise from the radial reference line CA to the line CB, moving from the radial reference line CA to CB. Remember that the rotation of theta P1 must be in this same direction, from the element's reference x-axis to the x dash axis. So when epsilon 1 and epsilon 2 are indicated as being positive as in figure 10.9a, the element in the figure 10.9b will elongate in the x dash and y direction, y dash directions. So you can see, sorry. So you can see we are saying that the elongations are positive, strains are positive. So when you will show it on the figure, you can see this is your x dash axis, this is your y dash axis. So on the x dash axis, you can see the positive strain elongation of the element in x direction, and on the y dash axis, you can see the positive strain. You can see the elongation of the element along the y dash axis. ठीक है जी? Any question about principal strains, orientation of the principal planes?
No, sir.
Next is the maximum in plane shear strain. So these 2 points E and F represents the in plane shear strain. As we have already designated that the shear strain downwards is positive and the shear strain upwards is negative. So this value of E will give us the maximum in plane value of the shear strain, whereas the value F will give us the minimum value of the shear strain. And orientation of the shear planes CE, this can be determined by moving from the reference line CA towards this CE. This will be 2 theta S1, and along with it you need to represent the sign convention, like whether it's clockwise or counterclockwise. This is clockwise, okay? And your 2 theta S2 will be moving from the reference line CA towards CE. So 2 theta S1 plus 180 degrees will give us the orientation 2 theta S2. ठीक है जी, and over this shear planes you have the maximum in plane shear strain and you have the associated average normal strain. You have the associated average normal strain. So maximum in plane shear strain. So the average normal strain and half the maximum in plane shear strain are determined from the Mohawk circle as the coordinates of the points E or F. The orientation of the plane on which maximum in plane shear strain and associated average normal strain X can be determined from the Mohawk circle by calculating 2 theta S1 using trigonometry. Here, this angle happens to be clockwise, moving from the reference radial line CA towards the line CE. ठीक है जी? Remember that the rotation of theta S1 must be in the same direction from the element's reference x-axis to the x-dash axis. Any questions about this now? About the shear maximum in plane shear strain? Okay, no questions. Then we are moving to the next part, that is strains on arbitrary. See, earlier you have derived the equations. Earlier you have derived the equations to calculate transformed normal and shear strains for any given angle theta. Let's say you calculated for theta minus 30 degrees and theta positive 60 degrees. Theta minus 30 and theta positive 60 degrees. So you got the values of a set of normal and shear strain values. Now, if you want to calculate this from the Mohawk circle, we know that theta on the element will be represented by 2 theta on the Mohawk circle. Theta on the element will be represented by 2 theta on the Mohawk circle. So theta, let's say, uh, let's take theta positive 30 degrees. So 2 theta will be 60 degrees positive counterclockwise. So moving from the reference line CA in the counterclockwise direction using the protector. You need protector as well. So you can mark the line point and then you can mark that line ठीक है जी, in whichever at whichever direction it's coming. So you will mark that point and then from the Mohr circle you will determine the shear this normal strain and then the shear strain. ठीक है जी? Just the important point to be noted here that that theta on the element will be represented by 2 theta on the Mohr circle. So the normal and the shear strain components epsilon x dash and gamma x dash y dash for a plane oriented at an angle theta. Okay, you can see this, they are saying any value of theta. Okay, and it is about x to x dash x is theta. Okay, so the normal and the shear strain components epsilon x dash and gamma x dash y dash for a plane oriented at an angle theta can be obtained from the Mohr circle using trigonometry to determine the coordinates of the point P. Point P क्या है? It's an any arbitrary point. Like you are given value of theta and you are required to calculate the coordinates of that point. To locate P, the known angle theta of the x dash axis is measured on the circle as 2 theta. ठीक है जी, in the same direction as it's on the element. This measurement is made from the radial reference line CA to the radial line CP. Remember that the measurements for 2 theta on the Mohr circle must be in the same direction as theta for the x dash axis to the x axis. Any questions from these first two points?
No, sir.
So now this point, basically they are saying that this point will give us epsilon x dash. ठीक है जी, epsilon x dash and gamma x dash y dash. But now if you need to calculate epsilon y dash, we know that x dash and y dash. So angle between x dash and y dash is 90 degrees. So over this plane you will have epsilon x dash, over this plane you will have y dash. So the angle is 90 degrees. So on the Mohr circle, this angle will be 2 times theta, which means on the Mohr circle, this angle will be 180 degrees. So if the value of epsilon y dash is required, so if you need epsilon y dash, so this is your arbitrary point P. You will extend it 180 degrees backward. So this is point Q. So the coordinates of the point Q will give you epsilon y dash. ठीक है जी? So if the value of epsilon y dash is required, it can be determined by calculating the normal strain coordinate of the point Q. The line CQ lies 180 degrees away from CP and thus represents a 90-degree rotation of the x dash axis. Is this clear?
Yes, sir.
With this, today's lecture is completed. Tomorrow we will solve the numerical related to the Mohr circle. ठीक है जी? So tomorrow we will do the Mohr circle, and other thing to be noted that tomorrow we will have an additional lecture in the break. ठीक है जी? Because we need some additional lectures to complete the course. ठीक है जी? So tomorrow we will have 2 lectures.
Okay, sir.
I have downloaded your attendance. If you have any question, please let me know.
सर कुछ स्टूडेंट्स कह रहे हैं कि मिक्स का सिलेबस कंफर्म कर दीजिए।
मिड का सिलेबस कितनी दफा कंफर्म करना है? स्ट्रेस ट्रांसफॉर्मेशन चैप्टर है पूरा।
ओके सर।
Okay, guys, thank you very much for your time, and I will see you tomorrow.